Now that I hope I've convinced you that plants have a form of short-term memory, let's move on to explore the possibility of long-term memory. Not the memory of seconds or even hours, but days, weeks, even months. Before I describe some experiments that demonstrate long-term memory in plants, I want to introduce another concept in plant biology that will be necessary for us to understand these experiments. This is a concept called apical dominance. This is a concept that is intuitively known by the gardeners among you, and releasing apical dominance is the basis of pruning. At the tip of a plant is the apical meristem, as we've learned in previous lectures. We can also call this the apical bud, and it's from here that all the new plant tissues grow. At the base of each leaf going down the stem, there's also lateral buds. Now, these lateral buds that are closest to the top don't grow, they're inhibited. But further down the stem, some of the lateral buds have started to develop, and these will form branches. If we cut off the apical bud, we release the inhibition on the lateral buds to grow. In other words, the apical meristem, the apical bud, the bud that's at the top of the plant or at the end of the branch, inhibits the development of the lateral buds. When we cut it off, then the lateral buds immediately start growing. And this is what you see when you prune a plant. When we prune a plant, we get bushiness because more lateral buds, more lateral branches have started to grow. So now that we've understood apical dominance, I want to describe a few rather obscure experiments. These were carried out first in the mid of the 20th century by a Czech botanist named Rudolf Dostal, who studied what he termed morphogenetic memory in plants. The morphogenetic memory is a type of memory that later influences the shape or the form of the plant. In other words, the plant can experience an external stimulus at some point, like a rip in its leaf or a fracture of its branch, and be unaffected by it at first. But when the environmental conditions change, the plant can remember the past experience and respond by changing its growth. Let me give you an example of the experiment that he did. So under normal conditions, with apical dominance, if the apical bud is pruned off, both lateral buds will grow evenly. But what Dostal noticed is that if he removed one of the cotyledons, one of the embryonic leaves, prior to removing of the apical bud, prior to decapitation of the apical bud, then only the lateral bud that would grow was the one that was near the remaining leaf. In other words, when Dostal removed one cotyledon, the plant remembered this mutilation and only developed in the direction of the remaining one. So are you convinced that this is memory? Well, Dostal's research was picked up by a French scientist named Michel Thivier. He's a member of the French Academy of Sciences. And what he noticed after decapitating the apical bud on his plant of choice, which is called Bidens pilosa, both lateral buds started to grow more or less evenly. But if he simply wounded one of the cotyledons, didn't remove it, then in this case, again, only the lateral bud closest to the healthy leaf would grow. He didn't have to completely mangle the cotyledon. He didn't have to remove it to get the response. It was enough that he pricked the leaf with a pin 4 or 5 times with a needle at the same time that he took off the apical bud. And this minor wound was enough to get the asymmetrical growth of the lateral buds. So where does memory come into this? Isn't this just another classic stimulus response phenomena? Well, during these experiments, Thivier extended the amount of time between the wounding of the leaf and the decapitating of the apical bud, even up to 2 weeks. And lo and behold, the lateral bud furthest from the pricked cotyledon would grow out, and not both lateral buds. Thivier knew that there had to be some way that the plant stored this traumatic experience of being pricked, and had a mechanism for recalling it once the central bud was removed, even if that happened many days or even weeks later. The following experiment really sealed the idea that the bud of the plant remembers which of its neighboring leaves had been damaged. This time, Thelier stabbed one of the cotyledons as he did before, but then he removed both cotyledons, the stabbed one and the untreated, several minutes later, and then only then did he remove the apical meristem. He found that the plant retained the memory of the stabbing. Once the apical bud was removed, the lateral bud opposite the original wounded cotyledon, that means the lateral bud next to the untreated cotyledon, grew more than the one on the other side, the one that was next to the stabbed cotyledon. So the jury, though, is still out on how this information is stored in the apical bud, but one promising option is that the signal is somehow connected to the phytohormone auxin.